Hi everyone and welcome to lesson 7. Today we are going to be looking at alkenes and alkynes. Alkenes and alkynes are unsaturated hydrocarbons that contain carbon to carbon double and triple bonds respectively. They exhibit distinct properties, structures and reactivity compared to alkenes. The first 9 straight chain alkenes are ethane, C2H4, propane, C3H6, but1N, C4H8, pent1N, C5H10, hes1N, C6H12, pent1N, C7H14, ot1N, C8H16, non1N, C9H18, dec1N, C10H20. The first 9 straight chain alkynes are ethane, C2H2, propane, C3H4, butane, C4H6, pentane, C5H8, hexane, C6H10, septane, C7H12, octane, C8H14, nonane, C9H16, decane, C10H18. Let's look at the properties of alkenes and alkynes. Alkenes and alkynes are generally more reactive than alkenes due to the presence of double or triple bonds, which provide sites for chemical reactions. They have higher boiling point and low melting point than alkenes and similar molecular weight. Alkenes and alkynes are generally insoluble in water but soluble in nonpolar organic solvents. They exhibit distinct physical and chemical properties based on the type and position of the multiple bonds. Looking at their different structures, alkenes have a carbon to carbon double bonds, while alkynes have a carbon to carbon triple bond. The presence of these multiple bonds introduces planar geometry around the carbon atoms involved in the bond. Alkenes and alkynes have linear branched or cyclic structures similar to alkenes. In naming alkenes and alkynes, the parent chain is selected to include the double or triple bond, and the longest continuous chain is preferred. The position of the multiple bond is indicated by the lowest possible number assigned to the carbon atoms involved in the bond, and the suffix ENE is used for alkenes, while the suffix YNE is used for alkynes. Let's look at geometric isomerism in alkenes. Geometric isomers are classified as 6 isomers or trans isomers. The 6 isomers, they have the same side of the double bond, while trans isomers, they have the opposite sides of the double bond. The presence of bulky groups or restrictions in rotation around the double bond leads to the formation of geometric isomers. Now let's look at the addition reactions and reactivity of alkenes and alkynes. Alkenes and alkynes are highly reactive towards additional reactions, where atoms or groups are added to the carbon-carbon multiple bonds. The electron-rich double and triple bonds make these compounds susceptible to electrophilic attack. Addition reactions include hydrogenation, halogenation, hydration, and many more. The reactivity of alkenes and alkynes increases with increasing electron density on the carbon-carbon multiple bond. Our next class will be alcohols, phenols, and esters.